So, our topic today is about the impending energy crisis, meaning that we're pretty much on the brink now where we're running out of viable sources to produce energy, and or we're running out of enough energy to supply the world as it grows in need. So as you can see from the quote, it says, "When the caterpillar calls the butterfly the end of the world, the master calls the butterfly." Meaning that the caterpillar thinks there's a change process that comes. So where you go from the caterpillar to the butterfly. It's not the end, it's just the start of something new. So my sources come from an MIT faculty newsletter, Business Insider, CNBC, talking about the energy problem, the Oxford Journal, Physics.org, Fusion for Energy, Peak Oil, the Exxon Valdez, the Deepwater Horizon, Chernobyl, the World Nuclear Association, Silence Alert, and a quote. So to start off with, like I said, the problem is there's an energy shortage production and also the continual harm being done to the planet. And the solution is that we should invest more in renewables, and we need to understand some of the alternatives that exist. The specific ones I'm going to be talking about are solar power plants with CNT technology and nuclear fusion, which is my favorite. So to begin, peak oil is basically the point in time when the maximum rate of crude oil extraction is reached, after which you're going to have a decrease in the amount of oil you can extract from all your wells across the world. And it's expected to peak sometime within the next 5 years. And then also, the U.S. has consumed roughly about 82 to 88% of its crude oil reserves. So we're also running short on oil here. And then by the end of the century, we're pretty much going to be out of oil, which is going to be exciting. And unfortunately, less than 2% of oil production comes from renewable sources. And it's very bad. So just to give a little bit of perspective, the U.S. consumes roughly 3.6 billion kilowatt hours of electricity. Unfortunately, with our grids being old and outdated and our economy growing, our population base growing, this is actually becoming an inefficient source. The world consumes about 15 terawatts of energy, which remarkably is not that much. However, that's without 2 to 3 billion people having access to power or to a reliable power grid. And electrical grids all over the world are highly burdened, especially in countries like India and China, and a lot of the African countries. So also, with having to produce more energy with all the fossil fuels we burn, we have high rates of pollution. They talk about climate change, global warming being solely caused by CO2 levels, which is untrue. It's just an accelerated change due to our activities. But it's not just CO2, as well as other greenhouse gases, such as methane and nitric oxide, which actually create a deeper greenhouse effect than CO2. The U.S. contains 4% of the world's population, yet we emit 22% of CO2 emissions. And CO2 levels have officially gone past 400 parts per million, which is the highest it has been in a few million years. And before the Industrial Revolution, we were at less than 250. Also, there is a cost problem prohibiting the advantage effects of renewable energy. A lot of the things we have, a lot of the renewables are very expensive to maintain. They require a large area. They're inefficient as of yet. But if you think that's bad, 2011, the United States paid $780 billion for oil products, most of which was used for transportation fuel. And then they also paid another $35 billion for coal, which was used to produce electricity. That amount of money can actually go towards helping better the planet and better sources of energy. Then you have some of the dangers from especially oil extraction. You have Exxon Valdez in '89. It's a tanker that ran aground in Prince William Sound, spilled over 11 million gallons of crude oil. They estimate about 1,000 miles of coastline.
This is a test of the Code Marine system. No action is required at this time. This is only a test.
Hundreds of thousands of Code Marine. So then you have the BP Deepwater Horizon spill in 2010. The platform, there was an explosion on the platform, sank the platform. In sinking caused a crack in the pipeline, and from that pipe, about 300 6.1 million barrels of oil were spilled, which equates to about 310 million gallons, making it the largest oil spill disaster in U.S. history. And about 20% of that is estimated to still be on the seafloor, which is going to have the effect is still being evaluated on sea life and ecosystems. And then finally, last example is going to be Chernobyl in Ukraine in 1986. But I know that there was an explosion at the plant, it caused a core meltdown, and 5% of the radioactive material was leaked out, blanketing the area. The only place that still remains highly radioactive is going to be right around the facility, and will remain so for a few hundred years. But there's a bright side. We do have alternative sources that are less harmful to the environment and can actually produce more energy for less. First would be solar. So all the energy the Earth receives comes from the sun. About 89,000 terawatts of energy falls on the Earth from the sun every day. However, global energy usage is only 15 terawatts. So if we can actually harness the full power of the sun, that would be great. Solar panels have zero emissions. Unfortunately, their current technology, they're very expensive and inefficient. They only convert about 14% of the energy they gain to electricity, and the rest is lost as heat, making solar farms extremely hot. The next one would be CNTs, which are carbon nanotubes. You can retrofit your current power plants with a device that will capture all the emissions from the plant and turn them into carbon nanotubes, which are relatively new, but they're being hailed as the next great material because they have about 20 times the strength of steel while being a fraction of the weight. But they're also useful in nanoelectronics, medicine delivery systems, and they're also being used currently in textiles, such as like bulletproof clothing. Also, however, they will be a good change of revenue for power plants because currently for natural gas power plants, every ton of methane they consume, they produce about $900 worth of electricity. However, they also produce about 2.7 tons of carbon dioxide. With a modification to the CNT, they would produce $835 of electricity, which is a drop. However, they'll produce a quarter ton of CNT, which is worth about $225,000. Industrial grade carbon nanotubes cost about $150 a pound, so for a ton you can get about $300,000. And their current production cost is pretty high because there's no real large-scale production. But if you did equip your power plants with this technology, it would drop it to about $2,000 a ton. And finally, we have nuclear fusion, which is basically the process that powers the sun. It's instead of like fission, splitting an atom, it's combining atoms together to produce energy, and fusion creates about 4 times as much energy as fission does. Also, it doesn't use radioactive isotopes or elements. It just uses isotopes of hydrogen, which are non-radioactive and actually in high abundance in Earth, mostly seawater. It's sustainable, so it can power a city for 100 plus years in just one source of energy. And then there's no danger for radioactive meltdowns. If the core is breached at all, the reaction simply stops. No less, no less. However, they're extremely hard to create here on Earth. You have to heat the core to hundreds of millions of degrees Celsius, which is 10 times hotter than the inside temperature of the sun. You also have to contain them within massive loops of magnetic coils, which is why the current project, the ITER, the International Thermonuclear Experimental Reactor, is about the size of a 10-story building. But it's the first attempt at a commercialized fusion reactor. So, just to wrap it up here, life is divided into 3 terms: that which was, which is, and which will be. Let us learn from the past to profit by the present, and from the present to live better in the future. So in summary, I gave you a problem, then I showed you some solutions, and finally I hope this shed some light on something you may not have known, may have known a little bit about, now you have a little more data, and hopefully